Hi, welcome back to the Network Plus Certification video series. I'm Mike Redmond, Master Trainer, here to help guide you through your successful journey of becoming a Network Plus certified technician. We're going to walk through a wide variety of topics, starting with basic network concepts all the way through network management and security. In this segment, we're going to talk about modern Ethernet. I'll describe the varieties of 100 Megabit Ethernet, discuss copper and fiber-based Gigabit Ethernet, and compare these to the competing varieties of 10 Gigabit Ethernet. Before we get too far, you need to understand a few things. There are only 4 Ethernet speeds, either 10 megabit, 100 megabit, 1 gigabit, and 10 gigabits per second. Every version of Ethernet uses either UTP or fiber optic. And every version of Ethernet uses either a hub or a switch. However, if you are going to use a hub, you need to understand that only the 10 and 100 meg Ethernet can use it. Every version, by standard, has a limit of 1024 nodes, and every UTP version of Ethernet has a maximum distance from the switch or hub to the node of 100 meters. First, we'll start with the 100 megabit Ethernet. The 100 base T4 uses Cat3 UTP and uses all 4 pair of wires. Now, this disappeared widely from the market after the introduction of the 100 base TX. That is the dominant 100 meg standard since about the late 90s. The term 100 base T now applies to that standard. So why the switch? Well, when upgrading from 10 base T to 100 base T, you had to switch out the Cat3 cable for Cat5 or better, replace all the old 10 base T NICs for a compatible 100 base T NIC, as well as replace the 10 base T hubs or switches to a compatible hub or switch. However, you gained multi-speed and auto-sending NICs, and the hubs and switches were fairly easy to upgrade. The advantage to multi-speed or auto-sensing is when first connected, it will auto-negotiate with the hub or switch. If both do 100 base T, then that's what they're going to use. However, if the hub or switch is only capable of 10 base T, the NIC will auto-negotiate down to the 10 base T speeds. Here's a look at a typical 100 base T NIC. So it's important to be able to distinguish between 10 base T and 100 base T. You'll have to inspect closely and you'll look for something indicated on the card usually. All modern NICs are multi-speed and auto-sensing, so regardless of the capability, you will be able to use either the 10 base or 100 base standard. Next, we'll talk about the 100 base FX. It's primarily centered around UTP versus fiber optic because UTP cannot meet the needs of every organization due to the 100-meter distance limitation and the lack of electrical shielding. Fast Ethernet refers to all the 100 megabit Ethernet standards. When moving into 100 base FX, you're going to have a few options to choose from, such as whether to operate in half duplex or full duplex mode. The early 100 base T NICs were half duplex. They could send and receive, but not at the same time. The IEEE added full duplex to the standard around the late 90s, and that's what you'll run into most often today. Again, during the auto-speed or auto-negotiation phase, the NIC and the hub and switch will determine whether or not to use full or half duplex. Of course, you can set this manually through the operating system. Next, we'll talk about Gigabit Ethernet. With Gigabit Ethernet, we've now moved to a new IEEE standard. It is the 802.3ab, or simply put, the 1000 base T standard. It uses all 4 pairs of unshielded twisted pair cabling, and it has a maximum cable length of 100 meters. Within the IEEE 802 standard, there are again several different substandards, starting with the 1000 base CX. Here you'll be introduced to what's called the twin axial cable. It's a shielded cable with a 150 ohm resistance. The maximum length of this cable is 25 meters. Since its introduction, this standard, however, has made very little progress. This is primarily due to the widely accepted 1000 base SX standard. It is a multi-mode fiber cable with a maximum length of 200 to 500 meters. Now, of course, that depends on the manufacturer. The device is going to look exactly like a 100 base FX product. However, it's going to use an SC as its common connector. For longer distances, we have the 1000 base LX standard. It is a single mode fiber, so it uses a laser to carry your data. It has a maximum cable length of 5 kilometers. Now, if you need to go farther, you can purchase special repeaters that will increase that maximum distance up to 70 kilometers. This is what you will typically find as the Ethernet backbone. With the introduction of fiber, there are some problems that we've run into with the ST and SC connectors. For instance, the ST connectors are large and they twist on. The installer must twist the cable, and by doing that, there's a danger of fracturing the fibers. With SC connectors, they snap in and out, but are also fairly large. Manufacturers wanted smaller connectors for more ports. So the solution is a small form factor connector referred to as the MTRJ and the LC. The MTRJ is the mechanical transfer register jack, and the LC the local connector. The local connector has taken on as kind of the de facto standard. And understand there are different fiber connectors available because manufacturers have created different types of connectors. However, the only 2 official IEEE standards are the ST and the SC. Here's a look at an MTRJ connector and an LC type connector. The Network Plus certification expects you to know and understand these different types of standards, the types of connectors they can use, and the maximum possible distance. Next, we'll discuss the 10 gigabit Ethernet. This is a standard that started showing up in a lot of high-end LANs. There are several different fiber standards to deal with, as well as 2 different copper standards. The 10 gigabit copper product has only been available since around 2008. With the fiber-based 10 gig Ethernet, the IEEE consortium issued a challenge to maintain the integrity of the Ethernet frame and how to transfer frames at such high speeds. A couple different solutions were suggested, such as being able to use the traditional Ethernet physical layer mechanisms, or what was already a workable solution, using a fiber network or a SONET that the WANs used. So the IEEE set the 10 gigabit standard to use the traditional LAN physical layer mechanisms. They also set the 10 gigabit standard to use SONET infrastructure over WAN fibers. However, it is understood that this quite possibly was a stopgap measure and recognized the need for additional or possibly even different networking solutions. So, in preparation, the IEEE created several different standards. Those standards are defined by the type of fiber used, the wavelength of the laser or lasers that are being used, the physical layer signaling type, and the maximum signal distance. All 10 gig Ethernet has the same naming convention. You'll see it annotated as 10G base and then an X for the type of fiber being used, followed by a Y, which indicates the physical layer signaling standard. For instance, R would be for LAN-based signaling and W would be for SONET or WAN-based signaling. The 10 gig base SY standard uses a short wavelength signal over multi-mode fiber. Here's a look at a 10 gig base SR NIC. Notice the different type of connector. For the 10 gig base L standard, it uses a long wavelength signal over single mode fiber. And for the 10 gig base EY standard, that is using an extra long wavelength signal, still over single mode fiber. When it comes to the 10 gig Ethernet connectors, these standards do not define the type of connector that must be used. These are set by the manufacturer. Next, with the copper-based 10 gig standard, it was introduced around 2006. It looks and works like slower versions of UDP, and the primary downside is that it runs on Cat6 cable, which only has a maximum cable length of 55 meters. However, you can opt for the Cat6A cable, which can go up to 100 meters. The Network Plus certification expects you to know and understand the different standards, cabling, and maximum distance of the 10 gigabit Ethernet. And just like fiber, when it comes to the physical connections of 10 gig Ethernet, there is kind of a hodgepodge of options. The problem that presents is a single router may need to support several different types of connectors, which means it's going to be more expensive. In response to this, the offered solution was a multi-source agreement. This agreement allowed the 10 gig Ethernet equipment to become the exclusive domain of high bandwidth LANs and WANs, and that's including the internet. Here's a look at what an MSA looks like. No discussion about these megabit and gigabit standards would be complete if we didn't talk about the backbones. A series of high-speed switches basically create a backbone. There are no computers, maybe a server or two, that reside on the backbone, and each floor will have its own switch connecting to every node on that particular floor. And then each floor switch has a separate high-speed connection running back to the main switch or core switch. Here's what a typical network configuration showing the backbone would look like. You see each floor with its own switch, and then each switch running to the core switch, which would then usually land in the server room. Here's a look at the dedicated switch ports that you'll find on today's Ethernet switches. it's important to know and understand your different types of Ethernets. Now you know the details of the different Ethernet versions. Be sure to use all the summary tables in your studies. Now I know so far I've only explained the basic functions of a switch. We're going to get into more details of that later. But we have to lay a foundation up front or you'll get lost in the other side. Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry, I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time.